Hello, friends. Today is the last day of a memorable year 2020. Many, many things have happened in this year, and many things we will remember. This year will probably become a turning point in the history. Despite all the challenges, we at GDA did not stop. We continued sharing knowledge. And since we are in the profession of sharing knowledge, what better way to end this year than to have a session of knowledge sharing? So welcome to today's knowledge sharing session. Today is the third day of our series where we are talking about risk, health, safety, and environment. Today we will be talking about the application of risk management at various workplaces, especially in our industry. The topic today is risk management applications at workplace. And in this topic today, we will be talking about what are the risks and what are the types of losses in the oil and gas industry. And then we will look at what are the typical workplace hazards. And especially we will look at manual handling injuries and controls because they concern the human aspects. And we will also look at common causes of fire and firefighting, what are the causes of fire and how to fight the fire. As you know that fire is the most prevalent risk, the severest risk in our industry. And lastly, we will look at the psychological health hazards and how to control them. So again, do not get overwhelmed with the amount of information I'll be sharing. Please use your common sense. And I believe that any great discovery has somewhere occurred to someone as a common sense. So please use your common sense and take whatever appeals to your common sense. Let's start with what are the risks and what types of losses we may suffer in oil and gas industry. If you recall, there was a huge explosion in the year 2005 at an offshore platform in Bombay High. And here you will be surprised to know the cause was very trivial. There was a barge nearby the platform where in the kitchen a cook cut his finger while preparing the lunch. And because it was bleeding and they did not have any medical facilities on the barge, which also was in violation of the law, they talked to the platform people and they said, no worry, just bring the barge a little close to the platform and we will transport this gentleman from the barge to the platform and will attend to his finger. And in the process of bringing the barge close to the platform, because it was high wind, the barge is stuck very strongly to the riser which was connecting the platform with the well below. And it was a very high pressure gas and that riser ruptured and it released the gas which was very volatile and very light and combustible, and it exploded in no time and they lost several lives. The platform was lost. So you see a small mistake, a small error of judgment can lead to catastrophe. This is another incident which happened in 1990 in the KOC. And as you know, in Kuwait, in those days, there were lots of fire. If you ever visit Kuwait Museum, you will see a video, a movie made out of that huge fire which was left behind after the invasion or during the invasion, which burnt almost for 1 year. Then we had this incident in Piper Alpha. Many people say this Piper Alpha incident in 1988 was the turning point in the, or rather a landmark incident in the history of health and safety. Many new standards, many new policies were framed after this incident. And again, this incident was also just a simple oversight of a some work which was done and was not mentioned in the permit, and also handover of the shift. And this resulted into a catastrophe. This is another incident in the Buncefield, 2005 it happened, where the tank farm burnt for weeks and suffered a lot of losses. So you see, oil and gas is not an easy business. It's a risky business. That's the message I want to convey. Let's look at what are the typical risks in different aspects of our industry. I'll start with the upstream. And as you know, we covered some time back a session on the upstream. And you recall, we start looking for oil as a first step, and that phase is called exploration. So in that phase, what are the typical risks? I will just go through very quickly. If you are surveying for oil and gas in an area which you do not know much about, if you select the area wrongly, you might miss. So that could be a big risk. Selecting a wrong survey area. You select the wrong survey grid or wrong survey technique. As you know that there are different kind of technique, gravity, magnetic, seismic. There are many techniques. Even in seismic, there are 2D, 3D. So, when you do this survey, you kind of lay a virtual grid, and you cannot survey every inch of the ground. So you make a plan, and you say that I will survey at every 1 kilometer or every half a kilometer interval, etc. But if that size which you assumed is inappropriate, you might miss a very high potential zone underground. So that is a risk. Incomplete and inaccurate survey data. The data itself, when you are collecting in these survey, if they are not complete and if they are not accurate due to whatever reasons, maybe the faulty instrument, maybe the people did not calibrate it properly, maybe they forgot to record, any of those reasons might contribute to the inaccuracy or incompleteness of the data, and that will never reveal the real potential underground. Inappropriate data interpretation tool. You got all the data correct, you got all the complete data, but you don't have the tool to interpret it properly. What's the use? Again, you will miss. Or you don't have the people to interpret it properly. Nowadays, of course, there are a lot of software which are used, but even with the software, unless you have the proper expertise to interpret these results, you will not be able to get the right benefit of the survey, and you may miss something very valuable. Now let's look at the drilling. What are the typical risks in drilling? So you have done the exploration, you found a area which is potentially containing the oil and gas. Now you want to do some more confirmation so that you can figure out whether it is potential and whether you can commercially go ahead with the production. So you do the drilling. And what are the risks? Inappropriate well planning. You may have planned, as you know that every well costs money. It can cost as much as $50 million or even more, depending on what type of drilling you are doing and where you are doing. Now, if you are inappropriately planning the well which location you have to drill. If that location is not properly designed or developed, then you might miss. Inadequate monitoring of vital drilling parameters. So as you know, as you are drilling, you are getting lots of information in terms of mud analysis, in terms of log, in terms of the readings on the drawworks, where you see how much, what is the kind of resistance you are getting from the ground when you are lowering the bit. All those parameters need to be monitored, and if you do not monitor them, and if you do not take the action in the time, you might lose the well. Poor testing and maintenance of BOP. BOP is the blowout preventer. This is the last line of defense from having a catastrophe in a well. If you recall, in the BP Mexico, where the spill happened, it was because they did not maintain the blowout preventer. And when the blowout happened, the BOP did not close properly. So why? Because they did not maintain it. So you don't maintain, or poor testing is a big risk. Poor casing and cementing. As you recall in the upstream session, as you drill the well, you need to keep on laying a pipe, a large diameter pipe, which will isolate the surface or the ground or earth of the well from the inside of the well, so that it does not collapse. And then you need to pump cement so that the casing is set and it becomes like a stable hole made of iron or steel. So this, if you are not able to do properly, if there are gaps, and if the cementing has not been done properly, so the pressure of whatever is there in the ground, whether it is water or gas, it may leak inside the well, and it might blow up the whole well. And then if you are not using the logging service, which need to be done while your well is being drilled before you set the casing. Now, if you don't do those logging at the time of drilling and before setting the casing, you might never be able to do those reading. You might never be able to get those readings ever after, because once you have set the casing and cementing, you lose that opportunity, and you lose a huge opportunity of collecting valuable data. And you might completely lose the well if you have a blowout. These are the typical risks of drilling. And of course, there are a lot of other risks, but I'm just trying to capture some of the top risks. Now, reservoir management. You have drilled a well, you have found that there is a good potential, commercial production can be made. And now I want to do some management of the entire reservoir to make sure that it can produce properly for a long time. But here the risk is, when I am doing the reservoir simulation, I am again selecting probably wrong model. There are different types of model for simulating the reservoir underground. As you know, what is there underground, thousands and tens of thousands of feet below, you cannot see. So you have to simulate it in a mathematical model on a computer. If you choose the inappropriate model, and there are different models, 2D, 3D, of course, nobody uses 2D nowadays. All of them are 3D, and even more, you can be using black oil, you can be using a compositional model. There are so many different varieties by different producers. And so you need to find which is your most appropriate model. And then the data, again, the same like survey, if you are not able to collect the proper data, which will be the input for this model, again, you will not get the result as you think is reliable. The size of the model, and again, the grid resolution, similar to surveying, if you have not done properly, you might not get the result. And every modeling requires some assumptions. because as I said, you cannot see anything, you cannot verify anything. So you need to make assumptions. And if you make too many assumptions which are not verifiable, then also you are running a risk of getting wrong data, a wrong result. And you are not keeping pace with the global R&D. Say, for example, you started using a particular technique of simulation with a particular model and never bothered to check in the world how the research and development happening, what new technology is coming. And as you know, this field is the most dynamic. And let me say that much before anybody else started using computer, it was the reservoir engineers who started using the computer in the most intrinsic way, in the most complicated way. They pushed the computer power to the limit, almost like NASA, in order to get the benefit of the mathematical simulation using the computer. And this field has been constantly evolving, so they need to keep pace with that. There was a time when you could not do simulation for a large reservoir in a very detailed manner, but today you can, thanks to the computer and mathematical simulation models. So let's look at what are the typical hydrocarbon risks in the oil and gas industry. Those risks were upstream. Now let's look at if the hydrocarbon comes on the ground. Once it comes on the ground, there are risks. What are the risks? The most important, the biggest risk is fire and explosion. And we concentrate maximum on this risk, fire and explosion. And that will happen when the hydrocarbon is released from the pipe or vessel. As long as it is in a vessel or in a pipe or in a confined space, which is sealed completely, no problem. It's like having a tiger in the cage. So long as the tiger is in the cage, locked out and secured, there is no danger. The moment the tiger is out of the cage, there is anything which can happen. It is exactly similar to the hydrocarbon. So what are the causes by which the hydrocarbon can be released or the tiger can be released? The most important cause is corrosion. The vessel, the pipeline, any of those containers can get corroded because they are made out of metal. They could be subjected to overpressure. The pressure inside the vessel or pipe could be so high that it ruptures. Or you do not maintain it properly and you make an error in maintenance, and thereby also there is a leak. Or something strike the vessel or pipeline, maybe some high power vehicle go and strike it, or something drops on it. So there is an impact, and due to that there may be a rupture. Or there could be a rupture due to natural hazards. Maybe there is an earthquake and the foundation of the plant or the tank or whatever containing the hydrocarbon shakes so violently that it ruptures. Or there is a tsunami or typhoon or a sandstorm. So normally whenever these plants, oil and gas industry or facilities are built, they do a lot of ground survey and make sure that in the worst situation of these natural hazards, they are protected. So they do a deep foundation and they make sure the soil is consolidated. So in case of such situation, there is no effect to the plant. And lastly, the sabotage, which is something which is human induced, and you need to take care of that. That is also a risk. Now let us look at what are the different types of fire and explosion which can happen in the hydrocarbon industry. One form of fire is called jet fire. What is it? It's simply a high pressure gas stream which gets ignited and then it impinges on equipment in the surrounding. So imagine a pipeline carrying a high power gas, high pressure gas, suddenly ruptures and it develops a hole, and through that hole, the gas stream is pumped out or is thrown out in a very high power jet, and it gets ignited. So it is like a flame, and this flame could be directed to any equipment which is lying in the surrounding of that pipeline, and that equipment now will get damaged because of this gas stream. So that's called jet fire. Flash fire. This is a flame propagating at a very high speed, just like lightning. You have a flash, just like on a frying pan. Sometime when you have a very high flame on the cooker and you put some oil, it suddenly flashes, it catches fire, and that flash is for a moment, but it's a very, very high propagating flame. Or you may have pool fire. Pool fire is basically a heavier hydrocarbon which can remain in liquid form in ambient conditions, but it is leaked and then it slowly evaporates. It slowly evaporates. It most of the time remains as liquid, but then it forms a pool, like a pool of water. So that pool of hydrocarbon liquid, it could be a petrol, it could be diesel, it could be a lubricant oil, it could be anything. Of course, the denser and heavier it is, the less vulnerable and volatile it is. But never mind, still it is combustible. So when it gets ignited, it can cause a fire. And that fire, of course, will be not as devastating as jet fire or flash fire, but still it can cause damage. Explosion. Explosion is the worst kind of fire. The previous three, jet fire, flash fire, pool fire, are something which you can control, not with much damage. But explosion is something which is almost uncontrollable. It just happens. You only have to count what you are left with after the explosion. And it normally happens when an hydrocarbon burns in a confined and closed space. When that happens, then there is so much pressure built up that it explodes. So the worst form of explosion is known as vapor cloud explosion. And this vapor cloud explosion is basically made out of light gases or light hydrocarbon. From C3 to C5, if you remember, C1 is methane, C2 is ethane, C3 is propane, then butane and pentane. So we are talking about propane, butane and pentane. These are still in gaseous form, or they can easily get into gaseous form even if they are into the liquid form. If suppose there is a vessel, there is a storage tank which leaks, and this liquid, which is probably in the liquid form inside the tank, when it leaks, it will immediately get converted into vapor, and that will form a cloud. And this cloud can move with the wind, and wherever there is a source of ignition, it will catch. And the moment it catches, it will explode like a bomb. And that can cause huge damage. That's called vapor cloud explosion. Blavy is another type of explosion where, let us say, and it's called boiling liquid evaporating vapor explosion. How it happens, it's a combination of, let's say, jet fire and a tank. Suppose there is a tank which contains any propane or, let's say, LPG or any liquid in a liquid form, hydrocarbon in a liquid form, and there is a neighboring jet fire. This jet fire, or there is a huge fire, this fire will make this tank heated, and when the tank gets heated, the liquid inside the tank will start boiling, and when it starts boiling, it will start releasing the gas which is dissolved in the liquid, and that gas, when it keeps on increasing inside the tank, it will pressurize it so much that it will explode like a bomb. Again, this will be causing a huge damage. Of course, not as big as the VCE, but is still quite extensive. So this is called Blavy. In short, we call it Blavy explosion. And then there is another type of explosion called boil over explosion. What is it? Most of the time, crude oil, it happens with the crude oil tank. So the crude oil is the heaviest form of hydrocarbon. It is the oil which comes out of the ground before refining. And this crude oil, when it is stored in a tank, normally along with the oil, there is some amount of water. Now this water segregates in the tank because water is heavier than oil. It settles at the bottom. But let us say there is a fire in the neighborhood, just like the jet fire or another tank is burning or something is happening in the neighborhood. And because of the heat, that heat will start making the tank also hot. And as this tank starts getting heated, the water which is deposited at the bottom of the tank will start getting converted into steam. And when that steam starts going, because steam now is lighter than the crude oil, it will start going through the crude oil. It will start bubbling through the crude oil. That bubbling over that through the crude oil will result into boiling. This is why it is called boil over. This boiling effect will make the crude oil break the roof of the tank and spill all over. And as it spills, it may catch fire. And once it catches fire, that becomes an explosion. So boil over explosion. That's also very dangerous. And sometime you might have noticed it at home while cooking, that there is something which has some trapped water, especially when you put something from the fridge directly on the fire. This type of thing can happen, that the water trapped into the solid or semi-liquid material can get quickly converted into steam, and that steam can rise through the little paste-like liquid in a boiling boil over explosion. It can cause boil over explosion. Now let us look at an example of this VCE, vapor cloud explosion. Enjoy this video. And there are several angles from where this picture has been taken, and from the CCTV camera. See how this is the cloud. This is the vapor cloud. See how fast it is approaching. It has not caught the, now it came in contact with the vehicle, and maybe one vehicle was, ignition was on and it caught fire. So the cloud itself is not dangerous, but when it finds the ignition, source of ignition, then it will cause the explosion. Look at another angle. People are not taking it seriously. Look how people are going back to take their looks as if it will take several minutes to reach. They think they have a lot of time. And see. Now this is the after effects of the explosion. And all of this happened in a few seconds. This is the severity of this vapor cloud explosion. Okay. Now let's look at the losses. What are the different types of losses which our industry can suffer when such fire and explosion happens? The one type of damage is the property. Our property, plant, buildings, machinery, they may damage. And the machinery can also break down either in a normal routine or because of such incidents. Our business might get interrupted. Let's say you have a client whom you have to supply your product LPG or jet fuel or diesel or petrol at a regular interval in certain quantity, and you are not able to. Then you are defaulting from the contract, and you may be subjected to certain penalties. So your business gets interrupted. And because the incident happened in your plant and that incident caused damage to properties of people outside your plant battery limit. Battery limit is the limit of your plant. If any damage happens outside to other people, that's called third party liability, and you might be liable to pay compensation. Your well completely may get lost and or start burning. And now to control that well, fire in the well, you may have to spend money to drill another well to control the fire in the burning well. And this is an extra cost which you might suffer. During the construction and of a project, there could be different kind of damages. For example, while transporting the equipment, it may suffer some damage during the shipping. Or while lifting a heavy equipment, the equipment may fall, the crane itself may fail. And as a matter of fact, yesterday, I was looking outside my window and there was a huge AC, chiller, big chiller unit from the roof of a building which was being lowered onto a truck by a huge crane. And what I was, very shocked to see, there were many cars which were parked very close to the truck, and the big chiller unit was brought hanging on top of those cars, and there were people also standing around. Imagine if by any chance the anchor of the crane which is holding the unit breaks or fail, how much damage it could cause. Excavation, when you are doing, and as you know, in construction or in any project, you need to do a lot of digging, and those digging might cause damage. There may be, you might be excavating into the basement of some other foundation, and some other structure might get affected because of that. And sometime when you do the modification in a plant, you are doing construction in a live plant, and that means that is called brownfield. It's a very interesting thing. You need to learn the greenfield and brownfield definition. Greenfield is a project where nothing else is there before. You start on a clean ground, clean slate, where there is no live plant built before. But if you are doing modification or extension or expansion in an existing plant, then it is called brownfield, because there is other structure already present. And if you are doing construction between those plant and facilities, there is a very high likelihood of damaging the existing facility. And then during the commissioning, this is the most dangerous phase, because when you are constructing a project or doing the construction, at that time there is no hydrocarbon used. At the time, this is only mechanical. You can have construction damage, etc., etc. But when you are doing commissioning, it is just before you are handing it over to the operation. And before that, you are introducing the hydrocarbon. It could be oil, it could be gas, it could be any form of hydrocarbon. And it is during this period that anything can happen because of the improper construction or gap in some quality. And this is supposed to be most dangerous phase of the project. So let's say you had these losses. Either you had the business interruption, or you had property damage, or you had explosion or project loss, whatever different kind of losses you have. How do you assess the value of that loss? So there are two terms which are used often to assess the loss. One is called estimated maximum loss. And by the way, these terms are used in the insurance industry because this is how they will make you payment. And you need to define this value at the time of taking the policy. You need to say that in my this property insurance, I am expecting a maximum of this loss. This is called estimated maximum loss. What is it? It is the largest loss that could result from one incident in the plant, one incident, not multiple. And it assumes that this incident is so large that the active protection system are rendered inoperative. And you know what is active protection? Active protection is like fire detection, fire sprinklers, foam release system. All of those are called active system. Whereas firewall, spacing, these are called passive system. So it assumes that all active systems are inoperative because the explosion was so big, and only the passive protection facilities such as spacing and fireproofing are to some extent effective. So it is in fact the worst loss which you can assume in your property during the operation, and you estimate it, and there are various ways of estimating. Mathematical models are there by which you calculate. The second type of loss is called probable maximum loss. Now this is less severe than estimated. This may happen many times. Estimated maximum loss is the worst possible, which may happen only once, perhaps rarely, very rarely. But the probable maximum loss can happen anytime, and it may happen many times in the life. And it assumes that the loss, this loss results in the failure of immediate detection and suppression facilities. But within a reasonable time, the secondary defense such as fire water facility, shut-off valve, etc., start operating properly. So the loss is limited. That's why it is called probable maximum loss. It's not severe. Okay. These two terms are used, and the way you do the insurance is based on these two values. You will, PML will help you decide how much deductible you need to put in your insurance policy. In terms of car insurance, let me put it this way. You agree with the insurance company that I accept to take up to 500 dinar, or let's say 50 dinar, up to 50 dinar, it will be my deductible. That means any loss, wherever it happens, up to 50 dinar, I will bear. And anything above that, you have to bear. And how you decide? You decide based on PML, that majority of the time, what amount of loss you might suffer in your operation. That will give you a hint that how much you should not pass to the insurance and you can absorb, because it's a small amount. But anything big, large, like write off the whole car, that you cannot absorb, that you pass on. That is the estimated maximum loss. Okay. Right. So we looked at what are the typical risk losses and you know, the situations in the oil and gas industry. Now we will look at normal workplace. What are the typical workplace hazards and risk control? So let's look at what are the hazards. One hazard is working in hot weather, working in cold weather, violence at work, substance misuse at work, that is like drug, movement of people, that itself is a hazard. If you have large number of people moving across different place or floors or corridor, that is a hazard. And general construction hazards. Working at height, if you have to work at a height, it becomes a hazard. And Working in excavations, when you are digging underground, that becomes a hazard. Each of these places have hazards, and we look at those hazards and how can we control those hazards. So let's start with working in hot weather. So first let's look at what are the effects, and then we will look at what are the controls. One effect of working in hot weather is dehydration. You get heat stress, heat stroke, muscle cramps, skin burns, or even cancer through the radiation. Okay? What are the control? Ventilation. Whenever you are working in a hot weather, make sure there is a proper ventilation, either through cross ventilation by opening the opposite sides of the window or a ventilator fan. Insulate heat source. So wherever the heat is emanating from, you insulate that source. Put some wall, put some kind of screen to allow heat to remain on the other side. Shield the heat source. Similar, instead of insulating, you are putting some kind of shield which will reduce the amount of heat coming to you. Cool refuse. So you build some places, small cubicles which are ventilated and probably even having AC. You might be seeing that almost every watchman in the plant has a small cabin with AC because this is his refuse. If he is standing all the time in the heat, he will probably collapse. So in between, he can go and take a rest. Plenty of water. And I can tell you that when I used to go for risk surveys in the heat of summer, sometime where the temperature go above 50 degree, we were instructed to drink at least 1 liter of water every half an hour. Can you believe it? 1 liter of water every half an hour. Because you sweat, you lose the water. You could be, and we were carrying water bottles all the time with us. If not 1 bottle, 1 liter, at least that 1 small bottle you must drink every half an hour. And then in the hot weather, the breaks are there. You might remember that during the summer, by law in the GCC, there is a official break in the work between 1 to 4, I believe, or 12 to 4. By law, nobody is allowed to work in the open area. Or you have rotation. Rotation means short duration. People are allowed to go out in the sun to work for less number of hours, and you rotate the people. And you provide the proper clothing, not the synthetic, but cotton and perhaps such that will protect your skin. And ITIS, you know from yesterday what it means. Can someone tell me what is the ITIS acronym I made out of? I'll say I is information, T is training, that next I is instruction, and S is supervision. So information, training, instruction, and supervision. This is something which is common with almost all controls. Now, working in cold weather, what are the effects and controls? The effects is freeze injuries, frost bites, slip and fall, hypothermia. That means you start shivering, your mood swings, you feel drowsiness, or you may even die. So what are the control? Warm refuse, opposite of cool refuse. Hot beverages, availability of hot beverages just like water. Breaks and rotation, same as hot. PPE clothing, here the clothing will be different. Sawdust on floor. So this is very important when you are working in cold weather, especially where there is ice or water possibility, you should have sawdust so that you don't slip and fall. Shield cold surfaces, similar on opposite to the hot. And again, ITIS. Violence at work. what are the risk factors, examples, and then controls, what are the examples of that. Cash handling. Whenever there is a handling of cash, there is a risk of violence, such as bank or cash counters in shops. Lone working. Whenever a person is working alone, especially in the middle of night, in a remote area, that's a risk, he can be attacked. And the authority that is such as police, they could be subjected to violence at work. They are exposed to the violence because they could be called in to control a crowd, and there a violence may erupt. Dealing with people under stress. So when you are trying to deal with people who are mentally subjected to high emotions, you don't know what and how they will behave. So there could be a violence. Dealing with people under drug influence, similar to the stress, and saying no. Now, this is very typical of places like in the bar, when someone wants a drink and there is a time and the time is up, the barman may refuse, and this might result into violence. This is just an example. Control, zero tolerance policy. So nearly, I cannot think of any workplace where they allow even a slightly chance of any violence. So zero tolerance. CCTV and security. You install CCTV at every vantage point so that later, first it will act as a detractor. When people know that they are being watched, they will not resort to violence because later it can act against them. Panic button. You need to have panic button at vantage point. Say for example, in the filling station, in the gas station, where the person is filling your car, there should be a panic button in case there is a violence which might result into him spilling the petrol on the ground. The moment he senses that there is a chance of violence or anything, he can press the button. Or I have seen in especially universities, in the campus of the universities, they have at every 50 meter or so a pole with a button which is called panic button. If suppose you are subjected to any kind of violence, whether bullying or whatever, you just press that button and immediately the police and security will reach within no more than 2 or 3 minutes because they know which place you are. Mobile or walkie-talkie. You carry always either a mobile or a walkie-talkie by which you can alert your friend, your supervisor, or whoever you are reporting to. And then there should be a security door. The door will not allow any miscreant to enter your workplace. So security door ensures that any passers-by cannot get in. And don't try to carry too much cash. I'm sure you all have followed this control when you are traveling in an unknown area where there is a lot of risk. No visit after dark. Again, do not visit places which are under dark and after dark unless it is important. And roll call. This is again very important, especially when you are on alone and you need to keep on telling your supervisor that you are present, you are where you are, and this helps. This helps your security. And pleasant environment. Maintain a pleasant environment, because when the environment itself is depressive, dark, and with discomfort, it instigates violence in people. So maintain an environment which is pleasant, with nice smell, air, light, etc. People will not normally resort to violence. So these are the control. Now, use of drugs and alcohol. So what are the effects and control? Late and lazy. These are the signs of people who might be under the influence of drugs and alcohol, you will see that they are coming late, or they are being lazy, they are being absent most of the time, the work quality is very poor, and their output has been reduced, they are not honest, they resort to theft because they want to buy the drug which they cannot afford. Their mood swings, one moment they are very happy, another moment they are very aggressive, and they misbehave. All of these are the signs of, they may not be 100%, but they are indicators of, might be there is something in the background related to drug and alcohol. So what are the control? You have a prohibition. Once again, zero tolerance policy. You have a legal prohibition. There is a policy prohibition and there is a legal prohibition. And these policies and legal notices are displayed all over at the workplace so that people are fully aware of the consequences. And then you do the random testing. So you, for example, especially on the New Year night, most of the time on the road, especially in the night, you will find on the highway, police will be waiting for you to get tested whether you are under the influence of alcohol and driving. So you have to be careful. Rehabilitation, and you need to rehabilitate, not hate somebody who is taking drug and alcohol, not condemn him. Try to rehabilitate him so that he comes out of it and becomes his better version. And in case with repeated warning and repeated, this formal and informal warning, the employee continue to repeat his actions, then you need to take a disciplinary action. ITIS, same, you have to give information, you have to train people, you have to instruct, and most of all, you have to keep on supervising. Now, movement of people at site, as I told you, large number of people moving at site itself is a hazard. And how we control? Again, hazard and control. So if a lot of people are moving at the site, there may be slips, trips and falls. There may be fall from height, collision with moving vehicle, striking by flying objects, striking against fixed or stationary object. So they can strike, hit. Control, you provide the surface which is slip resistant, or spillage control or drainage, proper drainage so that there is no possibility of accumulation. Designated walkways, so you have the footpath or designated lane where pedestrians walk. It is not coming in contact with a moving vehicle or any dangerous situation. Fencing and guarding, provide fencing and guarding so that people don't cross into the hazardous zone. Use of signs and PPE and ITIS. Now we continue. Movement of people at site. Public shortcut. Lots of people take that. There may be a traffic sign, traffic signal, but you don't want to go that far to cross the road. So you take a joy walk through the road, and that is public shortcut. Or there is a bridge and you don't want to use the bridge, instead you just cross the road. Right of way through site. This is another very important. Most of the pipelines, when they are laid in the civilian area, they have a fence around it and you are not supposed to go over them. But many people cut the wire, cut the fence, because again they want a shortcut and they go through the right of way. Or there is some property and it has clear sign of not trespassing and you go through it. Thief entering, curious children. What are the control? Strong perimeter, locked security gate, light at the gate and perimeter. Wherever there is darkness, wherever there is no light, there is a possibility of risk, big risk. Mobile equipment and secured. What does it mean? That means any equipment which can be moved, it should be locked. For example, your cycle, if you want to park the cycle, you should park it and lock it along with a pole so it doesn't move. Chemicals, if you have containers with carrying some risky and hazardous chemical, it should be properly kept, locked, sealed, and secured. And there should be CCTV, 24/7 security staff. Cover, barricade, excavation. If there is a hole or a big excavation done in the ground, it should be either covered with a solid platform so that people don't fall in it, or there should be a fence around it so that people don't fall it. And believe me or not, there are lots of cases, lots of losses of human life in the rainy season in many cities of India where this control is not followed. And last but not the least, you liaise with the schools. Why? Because children are supposed to be the foundation of young generation, and you need to teach them these control measures from the early childhood so that when they enter the work life, they are fully prepared and aware. In case of demolition, when you are demolishing a structure or a building, what are the hazards? Sharp objects. You may be encountering a sharp objects. Manual handling. Asbestos. Asbestos, you know, is a material which when broken emits a kind of fume which cause cancer. It dust actually, not fume, but dust. And this dust can go into your lungs and cause cancer. Explosives. You may encounter explosive. Rodents. Rodents are very dangerous when you are demolishing any old site. Falling structure, hazardous material, dust, working at height, noise and vibration, biological. There may be something biological kept somewhere and you might accidentally tip over it. Live overhead cable. There may be a cable running through that place which you are trying to demolish and it might be live. Plants and trapped energy. There may be some spring, for example, very, very tightly coiled, and it might just release when you touch it and it might cause injury. Now for falling material, what are the likely causes? The structure is weak, there is a gap in the platform, there is storing, you store the things at the edge. If you keep something on the edge of a platform, of course it will fall. Stacking too high, you keep one thing above the other, and if you keep on building this height too much, there is a chances of falling. Poor housekeeping, unprotected edge, incorrect lifting, lowering method. So what are the control for the working at height? Avoid working at height. Remember, ERIC PD, eliminate the risk first. That's the first stop. But if you cannot, then you and how you avoid working at height? By modifying the design. You modify the process. And if you want to prevent the fall, what you do, you put the guard rails. Wherever the platform is, you put a rails around it so that people are guarded. Or you put a toe board. You might have seen at the top of the platform, never you have the flat platform. It will end with a little edge which is protruded upward, and that's called toe board, so that even if something is small slips from the platform, it will be stopped at the edge by the toe board. Brick guard, and for the large object you put a solid brick wall at the end of the edge. At the edge you put a brick wall, or not brick wall, but maybe a height up to certain height, a brick structure, so that even if you are rolling something by mistake, it will not fall off the ground, off the platform. Minimize the distance of fall and its consequence by putting safety harness. So if you are working at height, you need to wear safety harness. So by accident, if you fall, your distance of fall will be minimized to the length of the harness. Or you put a safety net at the ground so that even if you fall, you will not be subjected to injury because of the net. So you either reduce the distance of falling or you reduce the consequence of falling. Now let's look at the ladder. We all use ladder either at work or at home. What are the safety control for the use of ladder? Always, this is very important. Please remember 3-point contact. What is 3-point contact? At any point on the ladder, at any time, you have 4 points, 2 hands and 2 legs. Either 2 leg and 1 hand or 2 hand and 1 leg should be on the ladder. That is what 3-point contact means. Top extending above roof. So the ladder should be of appropriate height. It should be so high that the top end of the ladder is above the highest point which you want to reach. And it should be put at an angle of 75 degrees, not too less, not too much. It should be secured at the top. It should not be loose. From the top, it should be secured by a rope or a chain so that it does not slip. And always put a ladder away from a live overhead wire. And it should be put on a ground which is flat or firm. And only one person should climb the ladder at a time. And while climbing the ladder, never carry any load. Why? Because you want to maintain 3-point contact. And for that, you need to have both the hands free. And don't paint the wooden ladder. If it's a wooden ladder, do not ever paint it. Why? Because if you paint, the hidden fault of the ladder, break, crack will be hidden. It will hide. So you will never know whether it is a good quality ladder. When you are working in excavation, when you are digging the ground, what are the control? What are the hazards? Okay, flooding. There may be water beneath which might flood the whole excavation suddenly. And if you are inside, you will get drowned. Or the whole wall may collapse over you. And hitting buried objects. Maybe there is something which is buried and you may hit that. People, objects falling in. Maybe people are watching from the edge and suddenly somebody falls in it. Hazardous substance. While you are digging, you don't know what is coming out of it. Maybe there is some pocket of gas trapped into a ground and it might emit. And there are many deaths in the workplace when such incidents happen because a poisonous gas might come out of it. Adjacent structure may collapse. You might be digging in one place, but because of your digging, the foundation of nearby structure is getting weak and that object, that structure might collapse on you. So what are the control? First, you need to have proper lighting. You need to have proper lighting. And you need to wear proper PPE, and most important PPE is the breathing apparatus because you want to protect yourself from poisoning gas. And you need to have permit to work. And also you need to put up some signage outside the pit so that people know there is work going on. And there should be a sloping. When you are digging a hole or making a hole in the ground, it should not be very vertical. It should be sloping. So people, even if they fall, they will not fall immediately inside. They will roll over. And it should be supported by some, kind of net or some scaffolding. And it should be barricaded on the outside edge. And there should be crossing point. That means if it's a large excavation, you should allow certain bridges, temporary bridges, solid, stable, so that people can cross over it through those points. And the secured ladder, when you want to lower some people inside, there should be a ladder which is secured. And we have seen the security of the ladder in the previous slide. So now let's look at what are the types of manual injuries while we are working with hand. When you are working with hand in any facility, there are many different type of injuries which can happen, and there are different controls which we must employ. And this I will show you through a video. So please enjoy this video, and I'm sure you will benefit from this video.
Many injuries like these could have been avoided if personnel were more aware of how to protect their backs. How often have you taken unnecessary risks when lifting objects or failed to correct bad posture and hazardous work methods? How often have you rushed into a manual handling situation without thinking about the possible risks or made the effort to find a mechanical aid? You need to be aware that many things can go wrong with your back if you don't think about safety and take care. Our purpose in this video is to help you prevent back injury by explaining how your back works, how to use it correctly, and how to keep your back in good shape through regular exercise and a healthy lifestyle. In particular, we'll be looking at the back structure, some reasons why back pain occurs, workplace hazards, how to assess and reduce the risks posed by these hazards in accordance with UK and EC guidelines, how to minimize the dangers of manual handling, and some pointers on back strengthening and stretching exercises which can be performed both at work and at home. Your back needs to be treated with care. It only has to be injured on one occasion, and you could be afflicted with back problems for the rest of your life. In order to prevent back injuries, it will help you if you understand how your back works. The back is a complex mass of over 500 bones and muscles, numerous joints, nerves, ligaments, tendons, and discs. There is plenty that can go wrong if you don't treat it properly. The spine is not perfectly straight, but its curved shape is designed to support the back structure. The key to proper lifting is to keep the three curves of your back in their natural position. This is something which weightlifters are very aware of, and why so few of them have back injuries. When the back is moved out of shape, then additional pressure and stress is placed on its component parts. How well your back stays on track depends upon the health of its support system. The spine is made up of vertebrae, which support the body and protect the nerves of the spinal cord. Nerve roots branch out through spaces between each vertebrae. As we can see with this model, they become more exposed and vulnerable as the spinal column bends. In between each of the vertebrae is a spinal disc. The discs are soft and pliable and act like shock absorbers between each pair of vertebrae. As you flex, the discs between the vertebrae are compressed. Discs have a gelatinous cushion-like nucleus and a fibrous outer ring. If this outer layer is damaged or becomes worn, then bulging or tearing of the disc can occur. This in turn causes pressure to build up on the ligaments and nerves, resulting in back pain. Imagine that the nucleus of your disc is like a ball. When your back is straight, approximately 80% of the load is borne by the center of the nucleus, and the outer ring has the job of holding the ball in shape. If your back is bent, however, then more weight is transferred to the fibrous outer layer, which is not designed for heavy loading, and damage can result. Because discs have a minimal nerve supply, they don't warn us when damage is occurring. You may have been abusing your back for years without receiving any warning of the danger. This abuse, however, will have led to a degeneration and weakening of your discs. Another problem is that our discs have no blood supply. If they get damaged, the healing process is very slow. Your back, stomach, and side muscles provide valuable support and are also an integral part of your back structure. Back injuries do not always happen due to a one-off strain. Usually they're the result of years of abuse. Awkward or abnormal posture, poor body mechanics, declining physical fitness, stress, overeating, and smoking. These are just some of the factors which can affect your back support system. This sort of abuse leads to a weakening and overstressing of the back and eventually to back injury. Let's take a look at some common workplace hazards which can lead to back pain. See if you can identify in each of these situations how the personnel involved are placing themselves at risk and what can be done to reduce these risks. In our first example, the workbench is positioned too low for the detailed work being undertaken. As a result, the trunk and neck are bent and the body is hunched. If this position is held for a prolonged period, then pressure will build up on the lower back and neck. To alleviate the problem, the workbench should be raised and angled to suit the employee. In the second situation, we see a repetitive task being undertaken in an awkward position. To improve the situation, a more upright and well-supported work posture should be adopted. Mechanical aids, such as in this case, a scissor lift, helps to keep the work level at mid-height so as to reduce bending and stretching. The employees in these scenarios are creating extra pressure on their necks, shoulders, and lower backs by having to repetitively lift objects above a comfortable work height. You can see how this person's neck is extended back and how his lumbar region is excessively arched due to the extra weight caused by lifting this load above his head. A work platform and adjustment to the loading system has helped to reduce the risk for this employee. In our fourth scenario, repetitive twisting and bending of the back is occurring. Rather than pivoting her back, this person should move her body around completely as she moves the load. This reduces the amount of twisting. In these situations, we see personnel adopting awkward pulling movements to shift loads. This is placing enormous strain on muscles and discs. Don't shock load your back by jerking a load or twisting your back. Use mechanical aids and levers to help move heavy objects and get extra help. Don't risk your back. Try and find an easier way of moving those heavy or awkward loads. Climbing up onto equipment and jumping down from it are frequent causes of injury. When climbing up, you are severely bending your back as well as stressing it when you exert force to pull yourself up. The same will occur when you climb down. Don't take shortcuts when you're climbing up. Use the ladders provided or get some other assistance. The most effective way of preventing manual handling injuries is to design the process or system of work so that the need for manual handling is either eliminated or dealt with by automation or mechanization. Ask yourself, is there a new approach to a particular job or sequence of jobs which could help to eliminate or reduce the manual handling risks in your work environment? There will obviously be situations, however, where the manual handling operation cannot be eliminated or fully automated. In those situations, it's important for the manual handling operations to be firstly assessed and then appropriate risk reduction measures introduced. How exactly do you go about assessing the manual handling risks which may be present in your work environment? It's important to have an inspection team which carries out regular inspections of the work area. The team should consult directly with personnel who are involved with the tasks. Personnel should also be encouraged to report any problems as early as possible. It may be useful for the team to consult injury and ill health statistics to help them identify manual handling risk areas. The inspection teams should be made up of representatives from management as well as employee representatives who are directly involved with the process. It's a good idea to develop an assessment checklist to be used by the inspection team, and this checklist can also be filled out on a regular basis by personnel and any new employees. Note these typical checklist questions. Taking this situation as an example, see if you can identify the manual handling risks to this employee. An assessment of manual handling situations will include taking account of posture, the force to be applied, the actions and movements involved, the range of weights handled, the nature of the object, the frequency of the task, the layout and condition of the workplace, and the age, skill, and experience of the employee involved. Once the manual handling risk has been assessed, then steps should be taken to eliminate or reduce the risk. Risk reduction can be accomplished by a combination of redesign, mechanical aids, and personnel training. The most effective way of reducing the risk is to redesign the equipment or the system of work. Redesign could include modifying the object, for example, making it lighter or less bulky. Modifying the workplace layout. At this firm, scissor lifts were introduced to minimize bending, and here we see a weighing machine set in the floor which has eliminated the need to lift objects in order to weigh them. Can the flow of materials be altered to reduce the risks? Where possible, the job should be redesigned so as to reduce bending, twisting, reaching motions, and pushing and pulling forces. What could be done in these situations to help reduce the manual handling risk? The next most effective way of reducing or eliminating manual handling risks is to introduce mechanical assistance or mechanical handling equipment. Here are some common examples. Taking this situation as an example, what measures do you think could be introduced to help reduce the risks? An obvious improvement would be to redesign the workplace layout so that heavy dies are placed at a more comfortable work height, and shelving could be fitted with rollers to reduce the pulling effort required to move the dies. Other improvements to the situation would include the use of mechanical aids such as this scissor lift, and ideally automation of the process. UK and EC guidelines also stress the importance of training in helping to reduce manual handling risks. While training is not a substitute for other risk reduction steps, it is important for personnel to be aware of correct manual handling techniques and know how to apply them. As well as lifting, manual handling can involve pushing, pulling, carrying, moving, or restraining. Firstly, stop and think. Plan the lift by checking the weight of the load. Are there any suitable mechanical aids which could be used? Have you checked the place where you're going to put the load to see that there are no obstructions? Stand close to the load with feet apart so that you have a balanced, stable base for lifting. Don't bend your back. Bend at the knees and keep your back as straight as possible. Get a firm grip and move the load close to your body. Think of the pressure on your back as the counterweight to the load you're lifting. The heavier the load, the more counterweight you need to help offset the load. Your back has a 10-to-1 lifting ratio. In other words, if an object you are lifting weighs 10 kilograms, then the pressure placed on your back when lifting will be 100 kilograms. However, this ratio increases the further the object is away from you, and correspondingly, the pressure on your back will also greatly increase. Don't jerk the load, lift it smoothly. Always keep your arms and the load close to your body, and when turning, use your feet rather than twisting the body. While each manual handling situation will vary depending on the load which has to be moved, you'll find that the 6 steps which have just been outlined will be applicable. In any lifting, pushing, or pulling situation, keep your back straight and use your legs and body weight to assist you. Where possible, avoid pulling a load. Pushing puts less strain on your back, and it also lets you put more force behind your body. Try and rearrange your workstation so that items you use regularly are within easy reach. Be especially cautious of reaching down and behind. This movement places a severe strain on your body. Try and use any available support. For example, in this awkward lifting situation, pressure on the back is reduced by placing a hand on the workbench to support the upper body as it lifts. Replacing the battery in your car is made easier by resting your thighs against the fender. They help to take some of the weight of the load and reduce tension on your back. It's also important to vary your tasks as much as possible so that muscles can be rested. Even when you're not at work, you need to keep thinking about back safety. Don't bend your back when getting something out from a low drawer. Bend your legs instead. When shoveling, lift with your knees and keep your back straight. Take the time to stop and stretch your muscles, and where possible, use mechanical aids. Remember, don't try and act the hero. If there is a potential risk to your back, then find a mechanical aid or get someone to help you. Before starting your shift, and also before you attempt to lift a load, you should warm up and gently stretch your muscles. Some useful stretching and warm-up exercises include head and neck turns, shoulder blade squeezes, bicep stretches, and back stretches. When you're doing exercises, think about what you're doing. Concentrate on your technique and on the particular muscles you're exercising. Try and also get plenty of exercise when you're not at work. By keeping in good shape and leading a healthy lifestyle, you'll be doing your back a big favor.
Okay, so there is a summary.
Because your back is such an important part of the body, enabling you to have freedom of movement, you have to think carefully about reducing manual handling risks. Remember to warm your muscles up. Be more aware of how you use your back and try and maintain a good posture. A few simple changes to your work layout, work habits, and lifestyle will help to save your back from injury and years of potential pain.
It's useful, sir, because we oftentimes take our backs for granted.
Absolutely, absolutely. We realize what damage we have done to our back only much later, by which time we have, already passed the opportunity to. So it's very important to share this knowledge with those who are entering into the workplace so that they take care of their back from the beginning and remain agile and strong throughout. Okay, now let's look at the next aspect of our risk, which is the fire, and how do we handle the fire if in case it happens. So first, let's look at what are the causes of fire. Now the fire is basically controlled by, or fire happens because of three things. And this is known as a fire triangle. This is a very famous fire triangle. I'll give you two and you tell me the third. One apex or one aspect of the fire is fuel. Either it's a solid fuel or a liquid fuel or a gaseous fuel, which burns. Second, you need air, either 21% oxygen or even 16% oxygen. So even 16% oxygen can supply enough material to burn, another possibility of burning. What is the third? Are these two enough?
Heat.
Absolutely. The source of fire, which is ignition, source of ignition. So if you want to, all three of these must come together in order to create a fire. So if you want to prevent the fire, simple, keep all these three away. Don't allow them to come together. And if you already have the fire, then how you fight the fire? Remove at least one. Either you remove the source of heat, or you remove the fuel, that is supply of fuel, or you blanket the air. So you cut off the air supply. Also, the fire will extinguish by itself. Now, what are the common causes of fire? That's how the fire happens. Poor housekeeping. Wherever you see loose papers, files, combustible material, or explosive or fire-prone material are lying around, not properly locked, not properly stacked, it's a cause of fire. Smoking. This has raised many fires in the industry throughout the history. And cigarette, you would be surprised to know, burns at 500 degrees centigrade. We think that it is simple cigarette. No, if you measure the temperature at the burning end of the cigarette, the temperature is 500 degrees. Imagine the heat it can provide. When you are doing the welding or cutting, by using a gas flame, or whenever you are doing an activity which involves friction, it can result into, it gives a source of fire, it gives a source of ignition. So if there is a gas around, or if there is any combustible material around, it can catch fire because you are creating a source of ignition. And if you are not aware of what are the fire hazards, that itself, ignorance itself can become cause of fire. And carelessness. Kitchen is a very big source of fire at homes. Electrical short circuit, again, is a very common cause of fire. And arson, which is deliberate ignition. Again, this is sabotage. Now, again, I will show you a video which will illustrate all aspects of firefighting. And again, I request you to look at it very carefully. You might learn something very interesting and important, even in the kitchen. If suppose, God forbid, any fire happens, what and how you should fight it, and what you should do in case you come across a situation where you are in a position to fight the fire, and how you should do it. So enjoy this video.
When we're making a video, if someone makes a mistake, we can simply shout "cut," sort out the problem, and roll the camera again. Unfortunately, if you're faced with a fire, you don't have this luxury. You must get it right first time. Although fire extinguishers are designed to be easy to use, you need to know which types of fire each is suitable for. Because using the wrong extinguisher is likely to cause the fire to grow, or it could result in you becoming a casualty of the fire. Training in the use of firefighting equipment is especially important to ensure that you have the necessary information to choose the correct extinguisher without putting yourself or anyone else in danger. This video is about the use of the different fire extinguishers you may come across around your workplace. And over the coming minutes, you'll see the different types of fire extinguisher available, how they're operated, how to apply their contents correctly to the fires you may find yourself facing, the safety aspects to be considered before attempting to fight a fire, and any safety consideration associated with the different extinguisher types. BSEN 3 was introduced in January of 1997 as part of the ongoing European standardization. It's the manufacturing standard for portable fire extinguishers. EN3 is not something new. In fact, it's been around since the late 1960s. While most of the requirements of BSEN 3 will not directly affect you, the way that the body of the fire extinguishers are now painted does. Before January 1997, fire extinguishers purchased by your organization were generally painted and identified according to their contents. For example, the water extinguisher was normally painted red. Foam was cream-colored. Dry powder blue. And CO2 was painted black. This is where you'll see the most significant difference in the extinguishers, as now all extinguishers must be painted red. The contents of the extinguisher are identified by a colored area, which can cover no more than 5% of the extinguisher body. The way the contents are identified varies quite considerably from one manufacturer to another. However, the color codes to which we've been accustomed for many years still apply. You will also notice there's no text stating what type of fire the extinguisher is suitable for. This information is now provided by these pictograms. For example, this pictogram indicates that the extinguisher is suitable for Class A fires, which includes materials like wood, paper, furnishings, and so on. This one indicates Class B fires, which covers fires involving flammable liquids. This one indicates that the extinguisher may be used on Class C fires, which are those involving flammable gases. Extinguishers which are suitable for use on fires involving electrical equipment will display this icon. As we mentioned earlier, BSEN 3 is a manufacturing standard and not a retrospective legislation. So, as long as an extinguisher is in good working order, it's not necessary for it to be replaced. It's therefore possible you may come across extinguishers of both standards for some time to come. For the purpose of this video, we'll be using fire extinguishers painted in both standards. Signage legislation requires that the position of fire extinguishers is indicated with either a solid red panel or a sign bearing this icon. Some sign manufacturers have produced signs like these, which indicate the type of extinguisher and the types of fire in which they may or may not be used. The firefighting equipment you'll come across around your workplace is known as first aid firefighting equipment. Like when there's been an accident, your action should be to prevent the situation getting worse until professional help arrives. Before you even think about fighting a fire, there's a few things you should keep in mind. Your first consideration must always be safety. The last thing you want to do is injure yourself or anyone else. Before taking an extinguisher, make sure that the fire alarm has been activated and that someone has called the fire brigade. You can well find that by the time you return to the fire, that it's grown larger. So the quicker help is on its way, the better. And if there's someone else nearby, get them to sound the alarm while you go and get the extinguisher. Make sure that the extinguisher you're about to use is the correct one for the type of fire you're about to fight. If you have any doubt about the extinguisher or what is burning, do not use it. Remember, using the wrong extinguisher could make the fire worse or result in you becoming a casualty. The fire extinguishers you'll find around your building are suitable for small fires and fighting fires in their early stages. So if your extinguisher runs out, you find that the fire is getting larger, other materials are becoming involved, or you feel that you're not getting control of the fire, leave the area immediately, making sure that doors and windows are closed as you go. If you can, it is a good idea to keep low. This way, you'll be able to avoid the smoke and to some extent the heat, which of course rises. Always make sure you have a way out directly behind you. Never allow the fire to get between you and your way out. Under no circumstances should you attempt to fight a fire that involves burning gases. The only action to be taken in these circumstances, and only if it's safe to do so, is to turn off the gas supply and call the fire brigade. Once an extinguisher has been operated, then it must be refilled. As you can see, with this type of extinguisher, a flag stating that the extinguisher has been used will appear. With the stored pressure extinguishers, you'll find that the pointer moves out of the green area once the extinguisher has been used. Fire extinguishers are designed to be simple to operate and use. First, remove the safety clip or pin. Aim the hose or nozzle at the fire. Squeeze the handles together and apply the contents to the fire. The way extinguishers are operated varies from one manufacturer to another, so it's important that you know exactly how your extinguishers are operated. The extinguishers you'll come across are known as controlled discharge extinguishers, which means that when you release the handles, the extinguisher will stop. The first type of extinguisher we'll look at is water. Water is the most common extinguisher in the majority of buildings, as the main risk from fire is usually presented by normal combustible materials. Materials which fall into this category include things like chairs, desks, papers, furnishings, and so on. The most effective way of extinguishing this type of fire is to remove the heat, and using water is the best way of doing this. Once you've operated the extinguisher, the jet of water should be aimed at the base of the fire, at the point nearest to you. Then moving the jet slowly from side to side, work your way to the back of the fire. As the flames begin to die down, you can move in closer. If you find yourself confronted with a fire that's growing upwards, for example on curtains, you should begin fighting the fire at its base and moving the jet from side to side. Work upwards until the fire is extinguished. You will often find that although the flames have been extinguished, the materials will continue to smolder for quite some time. So it's important to make sure that any hotspots are completely extinguished, as the fire may reignite. There are some fires in which water must never be used, because it'll either make the fire worse or it's potentially lethal. Most people are aware that water and electricity do not mix. The likely outcome of applying water on anything electrical is electrocution. And the reaction you will get by adding just a small amount of water to a flammable liquid fire can be terrifying. Not only will it intensify the fire, but it is also likely to cause the fire to spread and ignite other materials that it comes in contact with. If a flammable liquid is spilled and water is used, the flammable liquid will float on top of the water, causing the fire to spread. The most common size of water extinguisher contains 9 liters of water and will normally last for about 1 minute. And the jet of water has a range of about 10 meters. Water extinguishers are also available in 6 liters and will last for around 40 seconds. It's worth bearing in mind that the water extinguisher is fairly heavy. One this size weighs about 15 kilos. So if you find it's too heavy for you to lift and carry, do not attempt to use it, as you could injure yourself trying to do so. An additional method of fighting fires with water is the hose reels, which are fitted in many buildings. Hose reels have some advantages over the water extinguisher. They provide you with an indefinite supply of water with greater pressure. When you open the nozzle, the water will come out as a jet. If you continue to turn the nozzle, the jet will turn into a spray. The spray is ideal for damping down once the main fire has been extinguished, as the droplets of water will absorb the heat more quickly than the jet. And as you can see, the spray will allow you to damp down relatively large areas at a time. There are 2 methods of operating hose reels. With some, you must turn on the water by opening a valve that will be nearby on the pipework. And with others, the water will turn on automatically as the hose is pulled out. If you're going to use a hose reel, it's advisable to get assistance, as they can be difficult for one person to get to a fire, especially when there are doors, corners, or stairs to be negotiated. Tackling a fire involving electrical equipment is likely to be one of the more common uses of the CO2 extinguisher, and in most cases where you find 2 extinguishers together, one of those will be CO2. CO2 provides a safe non-conductive means of fighting the fire risks presented by the electrical risk in the modern workplace. It extinguishes fire by removing the oxygen and replaces it with a non-flammable gas. This gas is stored under extremely high pressure, which makes this extinguisher very noisy when it's being fired, which often comes as a shock to the operator. While it's being fired, the discharge horn of the extinguisher gets very cold. In fact, it can get sufficiently cold for your hand to stick, which may cause frost burns. It's a little like when you take ice cubes from the freezer, they stick to your fingers. Except the temperatures are much lower, so the damage to the skin tissue is worse. CO2 extinguishes a fire by removing the oxygen, and therefore should not be used in a confined space. The correct technique for using the CO2 extinguisher is aim the horn at the fire and then let go of it. Remove the safety pin. Squeeze the handles together and extinguish the fire. If you find yourself confronted with a fire like this, whenever possible, switch off and unplug the appliance. The CO2 should be applied through any available opening until the fire is extinguished. The reason for switching off and unplugging first is that electricity provides the ignition source to start the fire, so once it's been removed, the fire may well die out of its own accord. CO2 may also be positioned to cover the risk presented by flammable liquids. As we mentioned earlier, CO2 is stored under very high pressure and is therefore extremely powerful. So when using it on fires like this, don't put the nozzle too close to the fire, as you could cause the liquid to splash and spread the fire. So, stand back from the fire before you operate the extinguisher. Then move slowly towards the fire, moving the jet of CO2 from side to side in front of you. A point to remember with CO2 is that although the gas and parts of the extinguisher becomes extremely cold, it doesn't have a significant cooling effect on the fire. So if the liquid is in contact with hot metal surfaces, the fire is liable to reignite. As CO2 is a gas, it's not really suited for use on fires out of doors, as the cloud of CO2 is liable to disperse before the fire is extinguished. CO2 is available in a variety of sizes, and the size of extinguisher will depend on the size of the fire risk posed. For example, these larger extinguishers will normally be found in or near to boiler houses, main electrical intakes, or kitchens, where the fires are liable to be larger. The most common size of CO2 extinguisher is this one, which contains 2 kilograms of CO2. If it's fired continually, it would last for about 12 seconds, whereas this 5 kilogram extinguisher will last for about 25 seconds. The dry powder extinguisher in most workplaces is what is known as ABC powder, which means it is a multi-purpose extinguisher and can safely be used on fires that involve wood, flammable liquids, electrical equipment, and in the hands of those who've received specialist training, it can also be used on fires which involve gases. Powder is extremely effective on fires which involve flammable liquids. The technique for fires that are running and in a container differ slightly. With a running liquid fire, the technique is to start at the lowest point and work upwards, and moving it quickly from side to side, drive the flames away from you. If the fire is contained, stand back from the fire, which will allow the cloud of powder to build up. Then, using the same rapid side-to-side sweeping motion, drive the fire to the far edge of the container. And, as the fire begins to die down, you can move in closer. Remember to keep the jet of powder moving until the fire is extinguished. When confronted with a fire on electrical apparatus like this, whenever possible, switch off and unplug. Most of the electrical equipment you'll come across will be enclosed in some sort of casing, which the powder will not readily penetrate. So it's necessary to get as close to the fire as you can, without putting yourself in danger. Then the powder is more likely to penetrate the casing. Like the CO2 extinguisher, dry powder has no significant cooling effect, and reignition may occur, so be prepared to reapply the powder if the fire reignites. As you'll probably have noticed, the cloud of powder is rather large, and indoors this can impair your vision and cause everything in the immediate area to be covered in a very fine dust that can cause damage to sensitive electrical equipment, such as computers. Dry powder extinguishers come in a variety of different sizes. Small ones like this, which are often used for vehicle protection, will last for between 6 and 9 seconds, whereas one of this size, which is the largest you're likely to come across, will give around 12 seconds of continuous firefighting. Modern synthetic AFFF foam offers a very effective means of extinguishing fires that involve either normal combustible materials and flammable liquids. AFFF, which stands for aqueous film forming foam, extinguishes Class A fires, which you'll recall is normal combustible materials, by cooling the fire, and in the cases of Class B fires, which is flammable liquid fires, by shutting off the oxygen that the fire requires to continue burning. As foam is water-based, it's not suitable for use on fires involving electrical equipment. There are two different types of foam extinguisher, and although they contain the same type of foam, they have some important differences. The main difference is the part of the extinguisher which applies the foam to the fire. This is known as a branch pipe, which introduces air into the stream of foam, creating a frothy foam which is used to blanket a fire. This nozzle will produce a fine spray of foam, which seals the surface of the fire. The foam branch extinguisher is normally found where flammable liquids present a fire risk, like flammable liquid stores, boiler houses, kitchens, or petrol stations. When flammable liquids burn, it's not the liquid that is burning, but the vapors which are given off. And some flammable liquids, like petrol, will readily produce vapors, even at very low temperatures. So the idea is to stop these vapors from escaping by covering the surface with a layer of foam. If the foam is applied too close, or at the near edge of the fire, it's liable to be forced beneath the burning liquid, making it useless. So it is necessary to force the jet to break up. This is achieved by aiming the jet of foam at the back of the fire, for example at the back plate of a fat fryer, a wall, or any nearby adjoining vertical surface. Then, as the layer of foam creeps forward, it stops the flammable vapors from escaping and extinguishes the fire. There may be occasions where a vertical surface is not available. For example, if the liquid has been spilled, and in such cases the technique is to aim the jet into the air and allow the foam to drop onto the fire. An increasingly popular extinguisher is the foam spray, which is being used to replace water extinguishers in many workplaces. Its fine spray allows the user to attack a larger area of the fire than is possible with the jet produced by the water extinguisher. It not only cools the fire, but it also seals the surface of the burning material, thereby shutting out the oxygen. To apply the contents of this extinguisher, simply spray the foam over the surface area of the burning materials, moving the nozzle from side to side until the fire is extinguished. With flammable liquids, the technique is simply to allow the foam to gently flow over the surface of the liquid until the fire dies down. Most foam spray extinguishers have passed an electrical conductivity test, which means they may be used near to live electrical equipment. But as foam is water-based, it must not be used directly on it, as there's still a risk of electrocution. An effective means of extinguishing a fire like this is to shut off the oxygen by closing the cover or replacing the lid, or using a fire blanket. Modern fire blankets are made from tightly woven industrial fiberglass. To use a fire blanket, remove it from the container. Some blankets have tapes like these fixed to one side. If there are no tapes available, wrap the corners of the blanket around your hands like so. Then, using the blanket as a shield against the heat, gently lay it over the fire. Once the blanket is in position, the oxygen will be shut off and the fire will go out. Do not forget to turn off the appliance. Once the blanket is in place, it should be left until the container has cooled down, as removing it too soon will reintroduce the oxygen, and if the fat or oil is still hot enough, the fire will reignite. In the cases of pots and pans, they must not, under any circumstances, be moved, as the hot liquid is liable to spill, reignite, and possibly cause you serious injury. Fire blankets are also useful for wrapping around someone whose clothing has caught alight. In such cases, the technique is to help them to the floor. This is to stop the flames growing upwards to their head. As best you can, wrap the blanket around them to extinguish the flames. Then, carefully pull the blanket back and put out any clothing that continues to smolder and ensure medical help is on its way. If you don't have a fire blanket available, then you could use a coat or jacket. Just remember not to use anything that is nylon or polyester based, which is liable to melt and make the casualties' injuries worse. So to summarize, always make sure that the alarm has been operated before taking an extinguisher. Whenever possible, get some help and make sure that someone has called the fire brigade. Your priority must always be safety, so you should never fight a fire if you could be putting yourself or others in danger. And if there's any doubt about what is burning, then don't fight the fire. The various extinguishers around your workplace are provided for fighting fires in their early stages. Their discharge time is limited, so they may not last as long as you may expect. When fighting a fire, it's important to make sure you keep as low as possible. Heat and smoke will build up very quickly, so make sure that you always have a way out directly behind you. If your extinguisher runs out, you don't feel that you're getting control of the fire, or the smoke is getting too thick to see, leave the area at once, making sure that doors and windows are closed as you go. With fires involving gas, there's a danger of explosion and should not be fought with an extinguisher unless you've received specialist training. In most instances, if you can, shut off the gas supply, but do not extinguish the flames before doing so, as the escaping gas will build up and is liable to explode. Once an extinguisher has been used, then it must be refilled by the company which services your firefighting equipment before it's put back on the wall. The majority of fires you're seeing in this video have been filmed outside in the fresh air, where the smoke and heat do not present a particular hazard. But as you'll appreciate, the majority of fires you're likely to come across will be indoors, so the heat and smoke will be far more of a problem. Your prompt action with a fire extinguisher can prevent a small fire like this developing into a major incident. There is no substitute for practical training in the use of firefighting equipment. So if the opportunity arises, then take it.
That was the video of the firefighting. What do you think? Was it useful?
Well,
Yes,
sir.
sir. It was useful, but do we have any universal fire extinguisher? Because sometimes it's difficult for the people to identify what type of extinguisher they have to use. So, is there any universal fire extinguisher where that we can use for ABC fires?
As you can see, dry powder is one of them. You could use dry powder probably universally as it was indicated also. But then you cannot unless there are some ways, there are some new advanced material which people say can help. I have come across some people having some liquid filled in a glass tube, which breaks at 72 degree or so temperature, and it's like a capsule, and you just throw it in the fire, and it emits a cloud, and that cloud kind of envelops the fire and extinguishes it. I have seen it, and that can be used in almost any type of fire. I have seen that one. But in general, the fire extinguishers have to have different type. And two things I would like to highlight, especially about the dry powder. Dry powder, normally when you are keeping in the vertical position, what happens, the dry powder settles at the bottom, and let's say more than half of the cylinder is empty. It's with air, filled with air. So when the dry powder settles down and remains in that position for a long time, let's say 6 months or so, it forms a cake. And then at the time when you want to release it, because although there is a compressed air inside and it should release the powder, but because the powder is no more powder, it has become a cake, the powder does not come out. Do you understand? So what you need to do, wherever the dry powder extinguisher is available or is kept, it should be periodically tested and shaked. So what do? You take out the extinguisher and hold it in both the hands, and like a child, like rocking the child, you rock the cylinder from top to bottom on both sides. When you rock it like that, you will feel the powder flowing from one end to the other. You make sure that the powder is flowing. It is not heavy on one side and is light on the other side. It should flow easily from left to right or top to bottom. Make sure that this happens, otherwise this dry powder extinguisher is of no use. And second point, every extinguisher comes with a seal, and that seal should not be broken. If the seal is broken, that means this extinguisher is not reliable. Third thing is, every extinguisher need to be periodically tested, and the next date of the testing should be marked on the calendar, on the body, or on a tag attached to the extinguisher. You must make sure that it has been tested recently, and also its test validity period is still available. So you are not using an expired extinguisher or whose seal is broken, or in case of dry powder, it has become a cake. So remember these things. And I have seen many instances, important instances or important places. For example, I went to a supermarket where they had the fire extinguisher with the seal broken. And I pointed out to the supervisor that this extinguisher is of no use. And he understood what I was saying, immediately removed it. But many people, many times we forget to notice these things. So if you have a fire extinguisher at home, go ahead and check it.
Yeah,
Okay.
that's right, sir. In our building, we have seen fire extinguisher near to the lift, near to the ground floor, everywhere. So you said for dry fire extinguisher, we need to do regular maintenance, or once in every 6 months we need to do. What about other? I mean, do we need to do for carbon dioxide at any other fire extinguisher?
Yes. The
So
maintenance.
what they will do on that?
Correct.
I mean, in dry power, they said like it will form like a cake. What about other?
Correct. So most of the time, these extinguishers have certain gauge, and that gauge will have a indicator, either red or green. So long as the needle shows in the green, it's okay. But when it turns into red, that means it has leaked the gas and it is of no use. It will not work. You understand? So that is one indicator. And the other thing is that when these people come, they actually look at the body also, and they look at its strength and so many other tests they do. But these are indicators which are there on the extinguisher itself, and you can visually check it.
Okay, sir.
But in case of like foam, if the foam has been kept in the extinguisher for too long, that there is a shelf life of the foam, its effectiveness reduces and it needs to be changed. Even if the pressure is all right, because it has been kept for too long, the foam must be changed.
Okay. All right, sir. Thank you.
Okay. All right. Let's move to the last topic of our day, which is psychological health hazards and controls. What are the health effects of stress? The biggest psychological hazard is stress. And what are the effect of this stress on human psyche? So first, psychological effect is effect of stress is psychological. And what are they? Anxiety, low self-esteem, depression. So whenever you have anxiety, low self-esteem, and depression, be sure you are subjected to stress. Now, physical symptoms, you are sweating, you have high blood pressure, or you get a headache, or you get a skin rashes. Now, those are the signs of stress in your physical body. So when you see any of these, either on the body or in your mental state, you have the stress. Similarly, for behavioral, if you are not able to sleep, you get sleeplessness, or your mood swings very often, or you are tempted to use drug and alcohol, you are probably subjected to stress. You are suffering stress, and you need to do something about it. So be careful, make note of these things, and watch out. Watch out for these things in yourself and others. So what are the causes and control of the stress? First cause is the demand. And what is the demand? Demand of the work. You have a long working hours, that could cause stress. Or you have very narrow and short deadlines. Now that also may build up stress on you. So what is the control? Have a reasonable working hours and achievable deadlines. If you don't have those reasonable working hours and achievable deadlines, talk to your supervisor, negotiate what you are comfortable with. Because if you are working under stress, it's neither good for your physical health, nor it is good for the company, because your productivity and quality will suffer. Also, eliminate excessive hours or overtime or flexi hours. Often people get tempted to do overtime because of the money, but they forget that they are inviting stress in their life, and this might be doing a lot of damage in the long term. So sometime what we need to do is have people doing overtime who are not in regular shift, and thereby you can avoid the same person doing the overtime, or you make the flexi hours to suit different people's timing. Involve workers in setting targets. Now, whenever deadlines are set, it should be negotiated. It should be agreed by the person who is doing the work. Okay. Now, other cause can be lack of control. Now, what is it which you are lacking in terms of control? And how is that control to be applied? And what is the priority? You don't have control over priority. You don't have control over the lighting and temperature of the environment where you are working. Any lack of control on any of these could result into stress. So the control and the solution to that is you give workers more control. Of course, not 100% control can be given to the workers, but as much as required for them to remain healthy and safe. Those controls must be given. Involve the workers while preparing safe system of work. Remember SSOW we discussed day before and yesterday? So those procedures should be prepared in consultation with the workers. So often it has been observed that those who prepare these procedures probably have never worked on the shop floor, or they are far removed from the actual experience. And therefore it is very important to involve those who are working. Allow environmental control. Imagine you are working in an office where you cannot control the temperature or light as per your requirement. If those controls are made available to you, your life will become much more healthier and pleasant. And the final support, that means if you do not have proper instruction, proper information, proper training, and proper supervision, then that also could become a cause for stress. For that, solution is provide adequate ITIS, provide competent, all the necessary help. Whatever help is required, provide. Roles. If there are no clear definition of your roles and responsibility, you don't know. You don't know what you are supposed to do and what is your responsibility. In that case also, there will be stress. Solution, define the clear roles and responsibility. Also going forward, relationship. At the work, maybe there are peers, pressure. Maybe some people are being bullied by their colleagues or even the boss. So what is the solution? There should be a zero tolerance policy at work for such things. Confidential reporting. People should be allowed to report anonymously and without disclosing their identity. Team building outings. So often, regularly or from time to time, the supervisor or the manager should take the people out on a camping or some kind of outing where they can do the team building exercise, build the bonding, build the trust, so such bullying and relationship do not happen. Now, whenever there is a change, whether there is a change of company downsizing or a rumor of demotion or change in salary or whatever, it offers stress. It causes a stress. So again, solution is to minimize the change or manage the rate of change. Let's not have change, massive change at the same time. Spread it out and improve the communication. The result of stress, the result of a change can be, the consequence of the change in terms of stress can be hugely minimized if the communication is improved. If everyone is made to understand why the change is happening and why it will benefit them, so the stress will not be there. Consult the workers whenever the change is to be made, so that they become the change owners rather than the change victims. And family issues, the people, they may have their personal issues inside the family. We need to look out for that, watch out for that, and help them. And for that, solution is professional counseling. I am reminded of work practice in Japan, where there are professional counselors available in every workplace or most of the workplace, and they watch out for employees, such symptoms where they might be having some kind of family issue, and they not only provide professional counseling to the employee, but also they extend it to the family members, so that the relationship in the family becomes healthier, which in turn helps the worker perform better and remain healthy at work. And then one should do the special consideration. Maybe there are, mothers with the babies, or there are people with some physical disability, or there may be some, they are recovering from a long disease. Such cases, there should be some special consideration. And if necessary, if someone has a mental breakdown or a psychological condition, the company should probably even extend psycho help so that he may recover. Majority of the stress-related situations are temporary, and they can be rectified if they are caught at the early stage. But if they are allowed to grow, then they can become chronic and acute. With that, I close my presentation and session. Any question?
No comments from my side, sir. Thank you so much for the presentation again. I think I need to spend some time reviewing it. But yes, sir, the back regarding the spinal cord, the spinal injuries. Sir, how can, are there any specific kinds of chairs that is advised to be used? And is, sir, we there's also that back support pillows that is available in the market. Is that really helpful?
Absolutely. You see, of course, there are ergonomic chairs. These ergonomic chairs have several control. It controls the height of the chair. It controls the position and position of your back. It controls, it gives you the control of the arm, height of the arm, all these things, and the headrest. All these controls are available in ergonomic chair, and you can adjust it according to your own physical condition and workplace. Supposing that is not available, you can do some workaround. And the workaround, you can use some stool at the floor to keep your leg up so that it is your thigh should be at right angle, or right, rather than it should be in horizontal, parallel to the ground. It should not be going down or going up. It should be horizontal. Then you can put some pillow or some cushion on the back of your chair, so to give you some support. And you can raise the your computer and laptop by putting something on the table so that it comes on your eye level and you are not looking down or you are not looking up. So depending on where you are and how you are, you could use, and you could use some of your what you mentioned available in the market. Most important is make sure your body is in a relaxed position. Your spine is in a relaxed position, not under stress.
Sir, so that can be a gauge as well. If no part of your body is stressed, that means your position is correct.
I'm sorry?
Sir, for instance, can that be a gauge as well when
Yes.
your prolonged work,
Yes.
that no part of your body incurs any
Absolutely.
pain?
This is in my opinion, this is the best indicator of or best thing to watch out. Anytime any part of your body you feel stress, you are doing harm. It should remain relaxed. Even while we use our arm, it should remain relaxed. You should, of course, momentarily when you are pushing or pulling certain thing, you may feel, but believe me or not, if you are correctly doing it, using the correct technique, you should not feel the pain. Actually, you should feel like a flow. It should be a flow. I give you analogy of playing. I can give you example of tennis. Oftentimes when I used to make a shot, it will become a very powerful shot, but I wouldn't feel any power. It will go as if I have just cut the butter, and the ball will go with a very strong force. Why? Because I have used the correct technique. And sometimes I would feel a very big strain on my arm and shoulder, but the ball will not even cross the net. Do you understand?
Yes, sir. Yes, sir. And lastly, sir, what's the, because most of us work in front of computers more than around 8 hours a day.
Yeah.
What's the correct lighting? Is it in the front of the monitor, or behind you? What's the correct light? What's a suggested lighting, sir, when you're working on a PC
There
or on a
should
screen?
be the light should be behind the screen. The background of the screen should be lit, because if it is not lit, what happens is your eyes are focused on the screen excessively. You know, your pupils are like narrowing. But if your background is slightly lit, then your eyes become relaxed. You are looking at other objects also, and it helps you. And one technique, no matter where and how you are working on the computer, make it a habit to take your eyes away from the screen every uh, a minute or two, every couple of minutes, let's say. Take your eyes away from the screen, look at something momentarily, far, not near, far distance, and then bring your eyes back again. This will help your eyesight keep good.
Okay, sir.
And also your keyboard, the keyboard is very important. What I normally do is when I see it becomes dark and I cannot see the keyboard, that is also very bad. You need to look at your keyboard should be well lit. So there should be some table lamp or ceiling light which helps you lit your look at your keyboard very easily. You should not be straining on it.
Yes, sir. And
The
that's
worst thing you can do is to switch off all the light and then work on the laptop. That's the worst.
and lastly, sir, some because of sometimes it's a habit, but sir, when watching,
Even the TV watching should not be done in the dark room. It should be
Yeah.
with the ceiling light on.
okay, okay, sir, actually that was my third question when watching TV, because when we watch a cinema, when watching the cinema, it's all dark. So
No, we tend to do that. But remember, when you are watching a movie in the cinema hall, the amount of light reflected from the screen is much less than the light being emitted from the TV screen. The TV
yes,
screen is backlit, and there are, depending on the resolution of your screen, there are pixels which are being fed by power, and they glow and they emit radiation. So there is a powerful radiation light coming out of the screen many more times than the movie screen. And if you don't have the ceiling light or surrounding light, that will become piercing for your eyes after some time. And if you have, and you really don't need the darkness, because the TV screen is designed to be so bright that you can easily see it even in the daylight.
correct, sir. So those are the questions from my side, sir. Thank you so much. It was a very helpful 3 days, but I think it's worth it to go to revisit the video once it's edited.
Thank you very much for your kind words, Mitch. And any other comment, any other question?
No, sir.
Yeah.
We are really thankful for your great lessons for this last 3 days, sir. Thank you very much for the lessons.
Thanks, Ranjit. Rolly, you want to say something?
Same here. Just want to say thank you for putting this time and effort and enlightening us in many ways. It's been quite interesting this last 3 days session, and hopefully we can also start applying this in our daily life as well. Thank you, Raj.
Excellent. Martin, you want to have any question?
Actually, yes, sir. In addition to what Mitch concerned regarding the back problem, I think there's some exercises can help to
Yes.
strengthen your back. I think
Correct.
that should help in some other parts of your body. And I think the proper posture technique, if you can develop that, it can help even more.
Absolutely. And if you want to learn those exercises to strengthen your back, I personally do those exercises on a daily basis. And they are in my yoga video. Maybe you can watch them, or we can do another session for that.
Yeah, absolutely. That's good. Thank you very much, sir, for your for this session. This is very helpful for us, and we can apply it in our daily lives.
Most welcome, Martin. Amal, you have the last word.
Yes, thank you, Raja. I like this part the most, and hopefully I will apply most of it in my personal life.
That's good. That's good. Thanks, and thank you all of you for being such a nice, passionate team. I think whatever I am able to do is not possible without your contribution. And believe me, it is you who are tempting me or prompting me to share these things. So thank you once again, and Happy New Year. Let's carry forward the learnings of 2020 and build our higher castles of success in 2021.